Hey guys, a very good day to you all. In this video, we will be understanding a very short topic, that is Arrhenius Theory. Now, what is this Arrhenius Theory? The main motive of this Arrhenius Theory is to help us distinguish between a acid and a base. Okay, so let's see what Arrhenius Theory has to tell us. It says that acid is nothing but a substance which contains hydrogen and produces H plus ions when dissolved in water. So if any substance has hydrogen in it and after dissolving it in water, if it is giving out H plus ions, then it is an acid. For example, HCl, your hydrochloric acid. If you dissolve hydrochloric acid in water, it is going to give you H plus ions plus Cl minus ions, and the main requirement for an acid is that after dissolving in water it must give us H plus ions. So since HCl is giving us H plus ions when dissolved in water, therefore HCl becomes your acid. The next example is the acetic acid, CH3COOH. So when you dissolve this acetic acid in water, it is going to give us CH3COO minus ion plus H plus ion. So here also you can see that this acetic acid is giving us H plus ions, and as it is giving us H plus ions after dissolving it in water, therefore your acetic acid becomes a acid. Now this H plus ions that we are getting will be hydrated in water. Okay, so it will get hydrated because of the water molecules, and it will not be present as H plus ions. Instead, they will be present in the hydrated form, that is H3O plus, H5O2 plus, H7O2 plus. Now you might be wondering, how do we get this hydrated form? As mentioned earlier, these H plus molecules will combine with water molecules. Okay, so when you add a H2O to this H plus, you are obviously going to get H3O plus. As you can see over here, H2O plus H plus will give you H3O plus. And if you add one more water molecule to this H3O plus, you are obviously going to get H5O2. So if you add H2O to this H3O plus, you are going to get H5O2 plus. Similarly, if you add another water molecule to this H5O2 plus, then you are obviously going to get H7O2 plus. Okay, so these are just the hydrated forms of H plus ions. So H plus ions are not going to be present in water as H plus ions, but instead they will present in the hydrated form. Now on the basis of this, we have three different types of acids: the monobasic acid, the dibasic acid, and the tribasic acid. Now what are these different types? First of all, the monobasic acid is nothing but an acid which gives out one H plus ion after dissociation. For example, if you consider a molecule of HNO3, so when HNO3 is dissolved in water, it is going to get dissociated, and after getting dissociated, it is going to give us one H plus ion. Similarly, a dibasic acid is nothing but an acid which gives us two hydrogen H plus ions after dissociation. Okay, so when you dissociate H2SO4 by adding it in water, it is going to give us two H plus ions. Similarly, you might have guessed what is a tribasic acid. A tribasic acid is nothing but an acid which gives us three H plus ions after dissociation. Okay, now moving ahead, let's now understand what is a base. So we have understood how to identify a acid. Now it is time for us to understand how to identify a base. So Arrhenius theory tells us that a base is nothing but a substance that contains OH group. Okay, so any substance containing OH group, that is this group OH, and produces OH minus ions when dissolved in water, is called as a base. Like in the acid, we had a substance which has hydrogen in it. Here in the base we have a substance that contains OH in it, and after dissociation it will give away OH minus ions. For example, let's consider NaOH, the sodium hydroxide. So when you add this sodium hydroxide to water, it is going to get dissociated into Na plus and OH minus ions. So can you see over here, we are getting OH minus ions, and since we are getting OH minus ions, therefore this NaOH becomes your base. So I hope it was quite easy for you all to understand. Now again guys, this OH minus ions will not be present as OH minus in aqueous solution which contains water. So again, this OH minus ions will get combined with water molecules. As we all know that we are adding this NaOH to water, so water is our solvent. So this OH minus ions will combine with water molecules and will present in the hydrated forms as H3O2 minus, H7O4 minus, and H5O3 minus. And I hope you all know how we get this hydrated forms by simply adding H2O to it. So if you add a H2O to this OH minus, you are obviously going to get H3O2 minus. You can add, see, OH contains one hydrogen and H2O contains two hydrogens. So 1 plus 2, 3. So we have 3 hydrogens over here, and OH contains one oxygen atom and H2O contains one oxygen atom. So 1 plus 1 gives you 2. So that's why we get H3O2 minus. Similarly, if you add one more water molecule to this H3O2 minus, you are going to get H5O3 minus, and if you add one more water molecule to this H5O3 minus, you are obviously going to get H7O4 minus. So this is how your base is identified with the help of the Arrhenius theory. Now moving on, just like the acids, we have 3 types of base: the monoacidic base, the diacidic base, and the triacidic base. Now what is a monoacidic base? A monoacidic base is nothing but a base which gives us one OH minus ion after dissociation. For example, your cesium hydroxide. So when your cesium hydroxide is added in water, it is going to get dissociated and will give us one OH minus ion. Similarly, a diacidic base, a diacidic base is nothing but a base which gives us 2 OH minus ions after dissociation, like your barium hydroxide. So when your barium hydroxide is added to water, it is going to give us 2 OH minus ions. Similarly, a triacidic base, FeOH3, is going to give us 3 OH minus ions after you add it to water. So I hope you have understood these types as well. Now, although Arrhenius theory accounts for properties of many acids and base, it has certain drawbacks, or you can say it has certain limitations. For instance, the theory is applicable to aqueous solutions. As you have seen, we were adding the acid and base to water. So this theory is applicable to aqueous solution. Aqueous solution is nothing but a solution where water is a solvent. And it does not account for the basicity of substances like NH3, Na2O3, etc., which do not contain OH groups. Now what is the meaning of this? See, NH3 is a base. Na2CO3 is also a base. But what Arrhenius told is that a base is a substance which contains OH group. But these two substances, although being a base, do not contain OH groups. So hence, the Arrhenius theory was not applicable for all substances. So therefore, a next theory was developed, that is the Bronsted-Lowry theory. We will understand that theory in the next video. So guys, if you like this video, then please do not forget to subscribe to my channel and go check out my channel where I've uploaded 11th and 12th chemistry videos. They might be helpful for you all. And guys, thank you for watching this video. See you in the next video.